The power of blockchain securing your digital identity. Blockchain for securing digital identity offers a decentralized approach that eliminates single points of failure, ensuring enhanced privacy and security for users. Blockchain technology is praised by experts due to its security and the fact that blockchain technology is decentralized, which makes it more secure. This is because there is no central point of control and failure. Hackers would not find it easy to attack because every node in the network shall be required to be attacked to tamper with the data. Before moving forward, if you are new to our channel, don't forget to like and subscribe to our channel for future interesting videos. What is digital identity? A digital identity arises organically from the use of personal information on the web and from the shadow data created by the individual's actions online. A digital identity may be a pseudonymous profile linked to the device's IP address, for example, a randomly generated unique ID. Data points that can help form a digital identity include usernames and passwords, driver's license number, online purchasing history, date of birth, online search activities, medical history, etc. Biometrics, behavioral, biographic are the modals that make up a person's identity. How is digital identity created? In one example, users sign up to a self-sovereign identity and data platform to create and register a DID. During this process, the user creates a pair of private and public keys. Public keys associated to a DID can be stored on-chain in case keys are compromised or are rotated for security reasons. Additional data associated with a DID, such as attestations, can be anchored on-chain, but the full data itself should not be stored on-chain to maintain scalability and compliance with privacy regulations. What is a decentralized identifier? A decentralized identifier, DID, is a pseudo-anonymous identifier for a person, company, object. Each DID is secured by a private key. Only the private key owner can prove that they own or control their identity. One person can have many DIDs, which limits the extent to which they can be tracked across the multiple activities in their life. For example, a person could have one DID associated with a gaming platform, and another entirely separate DID associated with their credit reporting platform. Each DID is often associated with a series of attestations, verifiable credentials issued by other DIDs that attest to specific characteristics of that DID, location, age, diplomas, payslips. These credentials are cryptographically signed by their issuers, which allows DID owners to store these credentials themselves instead of relying on a single profile provider, Google, Facebook. In addition, non-attested data, such as browsing histories or social media posts, can also be associated to DIDs by the owner or controllers of that data, depending on context and intended use. How are decentralized identities secured? A key element of securing decentralized identities is cryptography. In cryptography, private keys are known only to the owner, while public keys are disseminated widely. This pairing accomplishes two functions. The first is authentication, where the public key verifies that a holder of the paired private key sent the message. The second is encryption, where only the paired private key holder can decrypt the message encrypted with the public key. How are decentralized identities used? Once paired with a decentralized identity, users can present the verified identifier in the form of a QR code to prove their identity and access certain services. The service provider verifies the identity by verifying the proof of control or ownership of the presented attestation. The attestation had been associated with a DID, and the user signs the presentation with the private key belonging to that DID. If they match, access is granted. What are the use cases of blockchain in identity management? Decentralized and digital identification can be used in many ways. Here are some of the top use cases that Consensus has identified. Self-sovereign identity, data monetization, data portability. What is self-sovereign identity? Self-sovereign identity, SSI, is the concept that people and businesses can store their own identity data on their own devices, choosing which pieces of information to share to validators without relying on a central repository of identity data. These identities could be created independent of nation-states, corporations, or global organizations. What is data monetization? As the world begins to examine who owns and should profit from user-generated data, blockchain-based self-sovereign identities and decentralized models give users control and carves a path to data monetization. Data monetization refers to using personal data for quantifiable economic benefit. Data on its own has value, but insights derived from personally identifiable data, substantially increases the value of the underlying data. There are quintillion bytes of data created each day by 4.39 billion internet users. Currently, the online data that we generate is intangible, invisible, and complex. Attribution is critical in the processes of ownership, and CSI makes it possible to attribute your online data to your DID. From there, individuals could monetize their personal data, for example, by renting it to ad training algorithms or choosing to sell their data to advertisers. Users would also have the option to keep their data hidden and protected from corporations or governments. What is data portability? Article 20 of the European Union General Data Protection Regulation grants users the right to data portability, which pertains to the data subject's right to have their personal data transmitted directly from one controller to another, when technically feasible. This right has the potential to enhance user experience, cutting down on the need to re-verify their identity across various services and platforms. With DIDs and verifiable credentials, it is possible to migrate identities that were anchored on one target system to another with ease. Data portability reduces friction for the user, while simplifying the sign-up process, which increases user adoption. Data portability also allows for reusable credentials, where a user can quickly re-verify themselves while meeting regulatory Know Your Customer requirements. This is especially useful to reduce customer onboarding time that avoids dropout rates and cut costs in the financial sector by skipping the cumbersome identity verification process, where usually a lot of documents need to be provided and checked. How does blockchain enable increased economic contribution? Digital ID is expected to contribute greatly to economic growth worldwide over the next 10 years, and it is considered inclusive, since it benefits individuals largely while stimulating economic activity for the global market. For example, a McKinsey study reveals that reaching the unbanked population in ASEAN could increase the economic contribution of the region from $17 billion to $52 billion by 2030. What are the benefits of decentralized identity? Regulations such as the EU General Data Protection Regulation, EU GDPR, strengthen identity standards that require modern identity solutions. Governments look towards distributed ledger technology to bestow identities to the unidentified and to protect citizens' personally identifiable information. Blockchain technology offers the following benefits: decentralized public key infrastructure, decentralized storage, manageability and control. Decentralized public key infrastructure. DPKI is the core of decentralized identity. Blockchain enables DPKI by creating a tamper-proof and trusted medium to distribute the asymmetric verification and encryption keys of the identity holders. Decentralized PKI (DPKI) enables everyone to create or anchor cryptographic keys on the blockchain in a tamper-proof and chronologically ordered way. Decentralized storage. Identities anchored on blockchains are inherently safer than identities stored on centralized servers. By using the cryptographically secure Ethereum blockchain, in combination with distributed data storage systems like Interplanetary File System (IPFS) or OrbitDB, it's possible to disintermediate existing centralized data storage systems while still maintaining trust and data integrity. Decentralized storage solutions, which are tamper-proof by design, reduce an entity's ability to gain unauthorized data access in order to exploit or monetize an individual's confidential information. Decentralized storage is one of the core components of secure identity data management. In a decentralized framework, credentials are usually stored directly on the user's device, smartphone, laptop, or securely held by private identity stores. Such private identity stores are referred to as identity hubs, such as Uport's TrustGraph or 3box. When solely under the control of the user, identities are considered self-sovereign. This, in turn, means the user can both fully control access to the data without having to worry about access being revoked. Data under the user's control makes the information more interoperable, allowing the user to employ data on multiple platforms, use the information for different purposes, and protect the user from being locked into one platform. Manageability and control. In centralized identity systems, the entity providing the identity is generally responsible for the security of the identity data. In a decentralized identity framework, security becomes the responsibility of the user, who may decide to implement his or her own security measures or outsource the task to some service like a digital bank vault or a password manager like app. If you enjoyed from this video, don't forget to like and subscribe to our channel for more content. Thanks for watching.